Hello everyone, this is Christina here, your GradSquare mentor, and today I'm here to take you through proportionality. So proportionality is one such major topic that has its wide applications over all the arithmetic topics, especially in time and work and time, speed and distance. So here I'm just taking you a small example of time and work and explaining proportionality to you. Okay, so first of all, my dear, let us define proportionality. Proportionality, you can take it of two types, direct proportion and inverse proportion. So what does direct proportion mean? See, when you have a particular value A, okay, if it increases and B also increases at a constant rate, then I can say that A and B are in direct proportion. Also, when A decreases, B decreases at a constant rate. So how do we represent that? We use it saying A is directly proportional to B, this particular expression. Okay, now using a real-time sample of distance is equal to speed into time. Okay, there are three parameters, distance, speed and time. Now, when you keep time constant, when the speed increases, the distance covered also increases at a constant rate. Similarly, when the speed decreases, the distance also will decrease at a constant rate. So here I can say that when time is constant, okay, speed is going to be directly proportional to the distance covered. Or I can use this particular notation, d is directly proportional to s, distance is directly proportional to speed. Now, in the same thing, we can also explain inverse proportion. When A increases, if B decreases at a constant rate, okay, then they're said to be in inverse proportion. Also, when A decreases, B got to increase at a constant rate. Okay, so for example, when distance is constant, if I have to cover a particular distance, if I increase the speed, I will take less time to finish the distance. But if I decrease the time taken, I'll take more time. So now I can say that when distance is constant, the speed is going to be inversely proportional to the time taken. So here we have looked at the definition. Now let's go and have a look at the application of the same. Okay, and I'll tell you no, proportionality can, any question proportionality can actually be solved using unitary math. It is very simple. So just an example for that. Let us take a sample of time and work. Okay, in time and work, most of the questions will have three parameters. One is men, the other is the work, and then the other is time. So when the number of men is constant, the number of men working is constant, you increase the total work, the time taken is also going to increase. Correct? So work is going to be directly proportional to the time taken. Similarly, when work is constant, when the total work to be done is constant, if I increase the number of men, the time taken will decrease. So I can say that the number of men is going to be inversely proportional to the time taken when work is constant. Okay, so there should always be a constant factor there when you're comparing two things. So I can use my basic unitary math saying there are three parameters, men, work and time. And now say I've got this question. 10 men can complete 4 assignments in 8 days. How long will it take for 4 men to complete 4 such assignments, 3 such assignments? Now, the basic data that I have is 10 men can complete 4 units of work in 8 days. Okay, now I need data for 4 men. So let's follow unitary maths for men there. First of all, if one man is there and the work is same, work is constant. Okay, when the number of men is decreased, okay, I know that the time taken has to increase. Here it's becoming 1/10. So here you'll have to multiply it by 10. So 8 into 10, 80. So if 10 men can complete a work in 8 days, one man will be able to complete it in 80 days. Okay. Now instead of one, I need 4 men there. So now keep the work constant 4 and increase the number of men. When the number of men increases, the time taken has to decrease. So here it is becoming 4 folds. So here it will have to be divided by 4. So 4 men can complete it in 80 by 4, that is 20 days. Okay, now the men part is got. Now I'll have to change the work. So let's go again with unitary maths here. So let's keep the men constant. If 4 men are there and the work to be done is 1, I have decreased the work. That means time taken is also going to decrease. So it has become 1/4. So this will also become 20 by 4, 5. So 4 men can complete 1 unit of job in 5 days. But I need 3 units, 3 such assignments. So keep the men constant again 4. Now the work done has increased. So obviously time taken is also going to increase. So this has become threefold. This will also become threefold. So 5 into 3, 15. So this is what is the answer. So 4 men can complete 3 such assignments in 15 days. Okay. So now this is no big deal. Okay. So any question that comes can usually be solved using unitary math like this. Okay. Now, if at all student find it confusing using this unitary math, okay, and you are comfortable with expressions, then what you can do is take this small example. I know that when your work is constant, when I increase the number of men, the time taken to complete that work will decrease. So men is going to be inversely proportional to the time taken. Similarly, when time is constant, when I increase the number of men, the work done also increases. So the number of men is directly proportional to the total work done. So from here, I can write it as M is proportional to W by T. Got it? Now, when I remove this proportionality sign, I need to assign a proportionality constant and let it be K. So M is equal to KW by T. Now I'll stop here. This is a constant, so it has to be the same for any given value of M, W, and T, men, work, and time. So now let's take the same question that we saw before. Okay, so the three parameters are men, work, and time. The first scenario, they've given 10 men can complete 4 assignments in 8 days. Okay, I have just taken down the data as it is. And in the second scenario, they've asked me how long time will it take for 4 men to complete 3 such assignments. Now, I'll have 2 scenarios. This is M, W, and T. So this is going to be M1, W1, and T1. So just go and substitute that in the above equation. I know that for this proportionality constant, K is equal to M into T by W. And that has to be the same for any given value of M, T, and W. So substitute M here is 10, T here is 8, and W is 4. Okay, first scenario. M1 is 4, T1 is going to be X, and W1 is going to be 3. Just substitute that, you will end up with X is equal to 15, my dear. Okay, so it is going to be very, very easy, my dear. So if you're comfortable with unitary math using numbers, use that, or if you're comfortable using expressions, you may do this. Okay, now here let's have a look at another one question. So this question looks a little more complex. Can I solve it using the same expression method? Let me see. 10 men begin to work together on a job, but after some days 4 of them leave the job. Okay, as a result, the job which could have been completed in 40 days. So 10 men could have actually completed the job in 40 days. But now it is being completed in 50 days. Okay, when 4 of them leave. How many days after the commencement of the work did 4 men leave? So let them leave after X days. Now let's note down all the data. I have 3 parameters, men, work, and time. So first scenario, 10 men could actually do the job in 40 days. And I don't know what is the job, so I put it as W itself. Okay. Now, second scenario, 4 of them have left the job. So 6 men are only there. And 10 men have worked on it for X days. See, the job actually could have been completed in 40 days. But they're working for X days. So X by 40 parts of the job is over. Now the 6 men will work on the remaining job. So the remaining job will be 1 minus X by 40 of the total job. So the 6 men will work on the remaining job. Okay. And the time taken for them. See, now they're completing 50 days. But already 10 men had worked on it for X days. So they're working only on 50 minus X days. So I've got both the scenarios. Now let me take that expression that I had derived initially. Okay, and I'll put it here. So M is going to be 10, T is going to be 40, W is going to be W itself. So this is M1, this is T1, and this is W1. Just go and put it down. So let me take this, my dear. 40 into 10 divided by W is equal to 6 into 50 minus X divided by, I can write this as 40 minus x divided by 40 into w. W and W anyway get cancelled. 2 goes here 3 times and 2 goes here 20 times. So this is 200 into 40 minus x by 40 is equal to 3 into 50 minus x. Now this goes here exactly 5 times. 5 into 40 is 200 minus 5x is equal to, this is now going to be 150 minus 3x. So 2x is now equal to 200 minus 150 is 50. So x now turns out to be 25. So solving this expression, I land up with x is equal to 25. So though this may look like a complex problem, my dear, if you really know how to figure out and write down the expressions, okay, then it's going to be very, very easy. So remember, proportionality is simple unitary math. If you find that confusing, you can also apply this, okay? But initially when you're trying it out, now try it in both the ways. And then after doing 10 to 15 problems, when you understand what is the logic and which method is much more better for you, then you may choose whichever and then move ahead with that, okay? But actually, I'll say that both are the same. In the first one, we're just using numbers and applying proportionality in each step. But in the second one, using expressions, we derive the overall expression for solving the problem and then you substitute the values. So no big difference between these, okay? So this is all about proportionality. I just wanted to make this concept much more simple to you because most students get actually confused with this topic. Okay, so proportionality is nothing but unitary math. So any question on proportionality can be solved in either of these ways. Practice more number of problems on both the ways, and then whichever is comfortable for you, take that and move ahead. Okay, and then this is one of the questions that has been coming more and again in the MBA exams. So cogged wheel questions. Okay, so here there are 3 parameters: the number of cogs. See here there are 32 cogs. No? Number of cogs, the time taken. Okay, see, time taken 8 seconds or minute and all, okay, and the number of turns it takes, so 80 times it turns and all, no? So these are the 3 parameters. So you try to do the same question in both the methods. Use unitary math, okay, using numbers and go step by step, or else using the same concept of proportionality, you make an expression and then go ahead. Okay, so please do this problem and check in, and if in case of doubts you can get that. Okay, so right, thank you so much. With this, I'll wind this video.